Thank you for the introduction. My name is Junichiro Moriyama, a PhD student of Kyushu University. Today, I'm going to talk about the study on the hydrogen absorption energy in iron chromium nickel ternary systems. In general, hydrogen decreases the strength and ductility of metallic materials. However, in some iron chromium nickel authentic alloys, hydrogen increase the strength and ductility, like this graph. And this effect is more pronounced when the hydrogen concentration increase, and the hydrogen concentration depend on the chemical composition of these alloys. Especially chromium tend to increase the hydrogen concentration and nickel tend to decrease. In order to understand the relationship between hydrogen and the materials property of these alloys, we have to consider why the chemical composition of these alloys affect the hydrogen concentration. So in the previous study, we calculated the hydrogen absorption energy in iron chromium and iron nickel binary systems. This energy is the required energy to incorporate the hydrogen atoms into the metallic systems, and the reduction in this energy means increasing hydrogen solubility of these alloys. As a result, chromium and nickel decrease the hydrogen absorption energy in iron chromium and iron nickel systems. This result indicates that in iron chromium and iron nickel binary systems. Then the iron chromium nickel ternary systems, there is a possibility each effect interact with each other. So the purpose of this study is to elucidate the mechanism of the dependence of hydrogen solubility on the chemical composition of iron chromium nickel ternary systems. In order to do that, we clarify the interactive effect between chromium and nickel atoms and the hydrogen absorption energy in ternary systems. First, we calculated hydrogen absorption energy in ternary systems, and next, we calculated hydrogen occupancy of the practical iron chromium nickel austenitic alloys by calculating the calculated hydrogen absorption energy. And finally, we estimate the magnitude of the effect of chromium and nickel atoms on the actual hydrogen concentration of these alloys. This is the calculation condition. In this study, we use the task software under the following condition. And we calculated the hydrogen absorption energy at the octahedral site consisted of iron, chromium, and nickel systems in this cell. And by changing the local atomic configuration of octahedral site, we investigated the interactive effect between chromium and nickel atoms and the hydrogen absorption energy. And this is the result, the calculation result. This graph shows a change in hydrogen absorption energy by chromium as a function of the number of chromium atoms consisted of octahedral site. In the iron chromium binary system, chromium atoms decrease hydrogen absorption energy. This is consistent with the previous study. And then in the iron chromium nickel ternary systems, chromium atoms also decrease the hydrogen absorption energy as the same way, but the slope is more gentle by the existence of nickel atoms. And this graph shows the magnitude of these lines slope, and the red point represents the slope and magnitude of the slope of this line. When the number of nickel atoms becomes 2, the slope is more gentle. And a similar trend was appeared when the number of nickel atoms increase. And this result indicates that nickel inhibits the reduction in hydrogen absorption energy by chromium atoms. And next we show the effect of the nickel atoms. This graph shows a change in hydrogen absorption energy by nickel atom as a function of the number of nickel atoms. In binary systems, the nickel decrease the hydrogen absorption energy like chromium atoms, and increasing the number of chromium atoms, the slope became gentle, more gentle. This result indicates that the existence of chromium atoms inhibits the reduction in hydrogen absorption energy by chromium atoms. In short summary, chromium and nickel decrease the hydrogen absorption energy independently, and each effect mutually inhibited in ternary systems. These two effects depend on the number of chromium and nickel atoms consist of octahedral site, so we can represent the hydrogen absorption energy in the octahedral site as a function of the number of chromium and nickel atoms. And this is hydrogen absorption energy equation. By using this equation, we can calculate the hydrogen occupancy of each octahedral site by using this equation. The hydrogen occupancy means the rate of octahedral site occupied with hydrogen atoms. By using two equations, we calculated actual hydrogen. We calculated the hydrogen occupancy of the actual iron chromium nickel ternary systems. In order to calculate the hydrogen occupancy, we assume the iron chromium nickel ternary system with random configuration of these atoms. In the ternary system, as you can see, there is various octahedral sites, and we can calculate each ratio of each octahedral site by using this equation and the atomic fraction of each iron chromium nickels. And second, we calculated the hydrogen occupancy of each octahedral site. By using two values, we can calculate the total hydrogen occupancy of the iron chromium nickel ternary systems. This value is equivalent with the hydrogen concentration because most of hydrogen atoms in the lattice site in austenitic systems. By using this procedure, we calculated the total hydrogen occupancy of the practical alloys, and this is the calculation result. The gray bar represents the hydrogen occupancy of the experimental value, and red bar represents the calculation results. As you can see, in all alloys, the experimental value consistent with the calculation result. That's to say, the change of hydrogen absorption energy by chromium and nickel atoms is the dominant factor of the chemical composition. From now, we will talk about the influence of atomic configuration on the hydrogen solubility. In this study, we assume the random configuration of these atoms. However, the actual austenitic alloy has a different configuration because of the different heat treatment condition. In order to consider the influence of the atomic configuration on the hydrogen solubility. We calculated the hydrogen occupancy at the ternary system with uniform distribution of chromium and nickel atoms by using two equations. This equation
2
means
minutes.
the equation means all of the hydroxide in ternary system has the same number of chromium and nickel atoms. To substitute this equation into the hydrogen absorption energy, we can represent the hydrogen absorption energy as a function of the atomic ratio of chromium and nickel atoms. We define the reduction part of hydrogen absorption energy. We define this part chromium equivalent. This is the index of hydrogen absorption energy at the ternary system. And by using this equation, we can calculate the hydrogen occupancy at the ternary system with uniform distribution. And this is the calculation result. In the red circle, the hydrogen occupancy at the random configuration, and the blue curve represents that of the hydrogen occupancy in the uniform distribution. As you can see, the hydrogen occupancy in the uniform distribution is lower than the random distribution, because in the random distribution, there is a little segregation state, local segregation of the chromium atoms. In this side, the hydrogen absorption energy is very small, so the hydrogen occupancy can increase. However, in the uniform distribution, there is no segregation site, so the hydrogen occupancy decrease compared to the random configuration. So we can conclude that chromium equivalent represents the concentration, hydrogen solubility concentration of ternary systems. Let me summarize this study. We calculated the hydrogen absorption energy in ternary iron chromium nickel ternary systems. As a result, chromium and nickel atoms mutually inhibited the reduction effect on the hydrogen absorption energy. And calculated the hydrogen occupancy was consistent with the previous experimental value in the previous study. And finally, the configuration of chromium and nickel atoms can influence on the hydrogen occupancy. Thank you for the